Okay, you guys are doing okay? Doing okay? Was that? This morning I was really hoping that they will close down, but
always just cancel classes.
was that? Cancel classes? I promise I'll give you one day off in April, okay? It's a Friday, yes.
Is it the Friday we already have off?
Friday.
Was that?
Is it the Friday we already have off?
No, it'll be a real off, yeah.
This day just came by today.
No, I have a conference in April that on Friday, and I'll be in Toledo, so we will cancel that day.
What was 7.1 and 7.2?
7.1 is integration by parts. 7.2 is trig integrals, like powers of sine, cosine, stuff like that. Before I start, I have an announcement. Instead of having the exam this week, we'll have the exam next week on Friday. I will. Boy, I didn't realize that you guys didn't want to have the exam this week. So, but we'll have the exam next week because I actually felt like it's a little bit too soon. So let's have it on Friday next week. And the exam will be over the same set of sections that I told you before the break. So what we want to do this week is finish up this section 7.4, and it's going to take at least till Friday to finish up this section. So last time we looked at the following example, and so here's the example that we looked at last time, and that example is that we had this rational function which is given by x squared plus 2x minus a 1 divided by 2x cubed plus 3x squared minus 2x. And last time, and I also sent you the video, and I didn't go over how we found the values of A, B, and C. So that's what I want to do today. Now let's recap with the steps. What is step number 1? The step number 1 is that we need to factor out the denominator completely. So I start with the denominator 2x cubed plus 3x squared minus 2x, And how do I factor that out? I factor out the common x first, then I get 2x squared plus 3x minus 2, and then I need to FOIL. Those of you who don't remember how to FOIL, note that if I multiply the coefficient of x squared is 2, the constant term is negative 2. So if I multiply them, I get negative 4. My goal is to find two factors of negative 4, so that when I sum the factors, I get positive 3. That is this positive 3 here. Again, I'm looking for two factors of negative 4, so that when I add them, I get positive 3. And if you think about it for a second, you'll see that the two factors of negative 4 I need is 4 and negative 1. So if I multiply 4 and negative 1, I do get negative 4. But if I add them, I get 3. So that tells me that I should rewrite the middle term as 4x minus x. Again, 4 is coming from here, minus 1 is coming from here. So 4x minus x. Now, we factor out from the first two terms and the second two terms. So we get, what can I factor out from the first two? 2x. And if I factor that out, I get x plus a 2. From the second two, negative 1, I get x plus 2 as well. Now that I have x plus 2 as the common factor of the two terms, I can factor that out as well. So I have x plus 2 multiplied with what? 2x minus 1. So at the end, my factorization is x multiplied with x plus 2 multiplied with 2x minus 1. So this is the complete factorization of the denominator of the fraction. So the fraction that I have, now I can rewrite that as what? Now I can rewrite that as x squared plus 2x minus 1 divided by x times x plus 2 times 2x minus 1. Everybody's okay so far? Okay, so far we have rewritten the fraction by rewriting the denominator in terms of its factors. Now the second step is that we need to write down the partial fraction decomposition of this fraction. So the step 2 here, step 2 is we need to write down the partial fraction decomposition of this guy. Now remember the guidelines. Each factor in the denominator will contribute certain terms in the decomposition. Each factor in the denominator contributes certain terms in the decomposition. What terms? So first of all, what's the contribution of the factor x? X is a linear factor and the exponent on x is 1. So for x, the contribution is a over x, where a represents a constant. Okay, someone please tell me what's the contribution of x plus 2? What's the contribution? Was that b over x plus 2, very good. And the last one is also a linear factor with exponent 1. So the contribution of that would be c over 2x minus 1. So what we are saying so far is that there is a value of a, there is a value of b, and a value of c for which this equation holds. Now we need to find these values of a, b, and c. Now how do we find the values of a, b, and c? There are two methods, and I am going to go over both, and you can compare and see which one you would like to use. Okay, so I'll go over both methods here. The idea is that first of all, you have to multiply both sides by the denominator on the left. So if I multiply both sides by this denominator, can someone tell me what I should be getting? On the left, what am I left with? On the left. Yeah, x squared plus 2x minus 1. On the left, what do I get with a? If you just tell me in terms of factors, you mean this, right? Yeah, it's very good that you were able to do that in your head, but let's write down the whole thing. And then you multiply b with what? X and 2x minus 1. And then c will be multiplied with x and x plus 2. Everybody's okay? So we multiplied both sides by the denominator on the left. So we get this. Now the two methods will separate, okay? So the first method, method 1, method 1 is that the two sides are polynomial functions, right? If two polynomial functions are equal, they will be equal for any value of x. So I am allowed to plug in any value of x on both sides, okay? And I will get a true equation. So, but there are convenient replacements of x that will allow us to solve for a, b, and c, right? For example, let's say I want to solve for a, right? What should I plug in for x? Yeah, because if I plug in 0 for x, then the second two terms, the second term and the third term will vanish, and then I'll just have the a term on the right. So if I plug in, as you suggested, x equals to 0, and if I do that, we are going to get on the left, we are going to get negative 1. On the right, if I plug in x to be 0 here, what do I get? 2 times negative 1, which is what? Negative 2a. And these two terms will vanish, right? When x is 0. So that tells me right away a is what? A is half. Alright, my goal now is to solve for b. So what should I plug in? Very good. So plug in x equals to negative 2. And if I do that, on the left hand side I would be getting what? Can someone tell me what do you get on the left when you plug in negative 2? Negative 1. Because negative 2 squared is positive 4, and then you have 2 times negative 2 will be negative 4, so they cancel out. And on the right hand side, when I plug in negative 2 here, I get, when I plug in negative 2 here, I get 0. And when I plug in negative 2 here, I get 0. So all I am left with is what? B times, right here, I get negative 2 here and negative 2 here. So what is that? Was that? If you plug in negative 2 here, negative 2 here, so you get negative 2 times negative 5, right? Which is what? Positive 10. Which is B is negative 1/10. In my previous lecture, I might have mistakenly written positive 1/10. I don't remember. So B is negative 1/10. Everybody is okay with that? B is negative 1/10. How do I get C now? We are going to plug in x to be 1/2. And if I do that on the left hand side, what do I get? I mean, you have to plug in half, right? And see, you're going to get 1/4 plus 2 times a half is a 1, minus a 1 cancels out. So you have 1/4. And on the right hand side, we know that the first term vanishes, the second term vanishes. So I am left with C times a half plus a 2. So what is that? Is that a half times a 5/2, which is 5/4? And that tells you C is what? 4 and 4 cancels out, so you get 5C is 1. So C is 1/5. So this is C, and this was B, and this is A. So now we could say our original fraction we had was what? Oh, by the way, so I found out the values of A, B, and C. Yes.
What is the for the plug-in x is 1/2 where are you
Give me 1 second, okay? You're talking about
what plug-in for x?
For C, you realize that in order to solve for C, you want to make the other two terms 0. So you have a 2x minus 1 in both of the first two terms. So if you plug in x to be half, then 2x minus 1 becomes 0. So right here and right here, if you plug in half, you get 0. So that's why we picked half in order to solve for C. Because if I plug in half here, it doesn't make x times x plus 2 0. Did that make sense? So if I plug in half on the left, I get a quarter, and then if I plug in half here, I get 0. If I plug in half here, I get 0. But when I plug in half here, I would be getting what? Half times half plus a 2. So that way, the coefficient of C is not 0, and I can solve for C. Yep. Okay, now I want to show you the second method, and let me use a different color for that. So method 2. Method 2. Remember this equation right here. We obtained by multiplying both sides by the denominator on the left, right? I am going to go back to that equation. So that equation was, if someone can tell me what that equation is, that equation is x squared what? Equal to a times x plus 2. Okay, bx, is it 2x minus 1 or 2x minus 1? Cx x plus 2. The second method depends on, basically, we go back to our grade school intermediate algebra or college algebra, where we multiply out, collect like terms, right? So what we are going to do on the right side is we are going to multiply out and collect like terms. Now, what is the largest exponent on x you can obtain on the right hand side? If you multiply out, what's the largest power of x you could get is 2. So I am not going to multiply out the usual way. I am going to figure out what should be the coefficient of x squared, what should be the coefficient of x, and so on. So I know that the largest power of x is x squared, and then I ask myself, what is the coefficient of x squared if I multiply out? Well, notice how many ways can I get x squared? From the first term, how many ways can you get x squared? Well, from the first term, the only way you can get x squared is when you multiply 2x and x, right? Which is 2x squared, and that will be multiplied with a. So you get 2a. Everybody realizes that. I cannot get x squared any other way from the first term. From the second term, the only way I can get x squared is if I multiply x and 2x, and then that will be multiplied by b, so I get 2b. And from the third one, I can get x squared if I multiply x and x here, so that's going to give me what? Plus a c. So that's the coefficient of x squared. Everybody follows that? You guys follow that, okay? Now for the second, now I need to figure out what's the coefficient of x. What is the coefficient of x? Let's see. From the first, go back to the first term here and figure out what is the coefficient of x. Or how many ways can you get x there? You can multiply 2x and a 2, which is positive 4, right? And you can also multiply negative 1 and x. So in total, what do you have? Positive 3x, right? That will be multiplied with a, so you get positive 3a. Did that make sense? Again, from these two terms, you can get x by multiplying 2x and 2, which is 4x. You can also get x by multiplying negative 1 and x. So it's 4x minus x, which is 3x. And that's going to be multiplied by a. So you get 3a. From the second term, what's the coefficient of x? It's actually negative b, right? It's negative b, and from the third term, what do we get? Plus 2c. Yes, plus 2c, bx, negative b, yes. Okay, so now the last thing to do is, what would be the constant term, right? From the first term, what is the constant term? Negative 2a, right? Negative 2a from the first. What is the constant term from the second one? What's that? None, right? 0. And there is no constant term coming from the third term. So this is it, negative 2a. Now, on the left-hand side, I still have x squared plus 2x minus a 1. When two polynomials are equal, the coefficients must be the same. So I could say that 2a plus 2b plus a c is equal to what? 1. I could say 3a minus a b plus a 2c is equal to 2, and negative 2a I can say is what? Negative 1. So basically I come up with a system of equations if you have this system of equations, when you take differential equations, you're going to apply linear algebra tricks to solve this system. But I don't want to, start teaching you what you're going to learn there. But solving this is pretty easy, right? You have seen how to solve this type of equation systems before. Well, first of all, is it clear that I can say that A is what? A is half. Now what I'm going to do is I am going to plug in the value of A in the first two equations, okay? Now, if you plug in the value of A in the first equation, right? What do you get? You get 1 plus 2B plus C equals to 1, right? And then the 1's cancel out. So I am actually going to get what? 2B plus C equals to 0. Okay, so what we did is we plugged in the value of A in the first equation here. And if I plug in A half, I get a 1 here. Right here I get a 1. But that one and the one on the right cancels out. Now I do the same. Now I plug in the value of A in the second equation. And that's going to give me 3 half. And so what do I get? I get negative B plus a 2C. When you plug in half, 3 half, what is 2 minus 3 half? You get a half here if you simplify. Now I have 2 equations and 2 unknowns, right? And I can easily solve for B and C. So what I'm going to do here is I know that A is a half. And this is what I'm going to do. I'm going to write down the first equation as it is. I am going to keep it as it is. And I am going to multiply the first equation here. Right here, I'm going to multiply the first... let me take that back. I meant to say I'm going to multiply the second equation by a 2 and add it to the first equation. So multiply this equation by 2, add it to the first. What do you get? Do I get 5C? Okay, and I also get what? 1 on the right. Because half multiplied by 2 is a 1, and 1 plus 0 is 1. So then, what do I get? I get A to be a half. Now I have C to be a fifth. And now I can plug in the value of C in the first one in order to obtain B to be what? Negative 1/10. Again, I didn't show you the details of that, but you can imagine you can plug in 1/5 for C in the first equation here. You plug in C to be 1/5, and then you can solve for B. Everybody's okay? Yeah.
Alright, so when you have like 2A plus 2B plus C equals what? How do you get that?
You're talking about this one?
Yeah.
Oh, these two polynomials are equal. So the coefficients, what's the coefficient here? 1. The coefficient here is this. The coefficients must be the same when two polynomials are equal. Okay? And notice that we set the coefficient of x here, the coefficient of x here, and then the constant. They must be the same. Okay? Yeah.
The negative b plus 2c equals 1.
Yeah.
Where do you want to
Basically, once I have this step here, right? Now I have 2 equations in 2 unknowns. You must be used to do the following, right? You can solve for C in terms of B and then plug that in, right? Substitute. Instead of doing that, what I did is I looked at these two equations here, and this is what I'm doing. I am multiplying the second equation by 2 and adding the result to the first. Multiply the second equation by 2 and adding the result to number 1. The reason is, if I do that, then b cancels out. So my goal is to get rid of one of the variables. So I am getting rid of b, and if I get rid of b, then I only get a c term, right? So when you multiply this guy by a 2, you get a negative 2b, added to this guy would be 0. When you multiply this guy by 2, you get a 4c plus a c, you get a 5c. When you multiply this guy by a 2, you get a 1. 1 plus 0 is 1. So that's what I have here. Everybody's okay with that? All right, so this is the same answer that we had before. So now we need to go back to our original fraction, x squared plus 2x minus 1 divided by 2x cubed plus 3x squared minus 2x. What did we find for a? We found that a was a half. So a was a half divided by x. We found b was a negative 1/10, right? And remember, underneath b we had, can someone tell me what did we have? X plus 2. And the last one is 1/5 and 2x minus 1. So basically then we have x squared plus 2x minus a 1 over 2x cubed plus 3x squared minus 2x, which is 1/2 times 1 over x plus negative 1/10 times 1 over x plus 2 plus 1/5 1 over 2x minus 1. You guys agree with that? Yeah.
Does it matter on the left-hand side for the denominator if we have it like that, or if we have it just more simplified and the factor?
At this point, I have, you see, the reason I factored out was my goal was to come up with the decomposition. Once I came up with the decomposition, then on the left-hand side, I don't have to have the denominator factored out.
Does it matter either way?
Either way, it doesn't matter, yeah, because the denominators are the same. Again, the whole goal was to be able to integrate this fraction. So if I want to integrate this fraction now, right, I have dx then, I can simply integrate this guy. So instead of integrating the fraction directly, we can integrate the decomposition. And so what do we get? We get half integral of 1 over x dx, negative 1/10 integral of 1 over x plus 2 dx, plus 1/5 integral of 1 over 2x minus 1 dx. And can someone tell me what's the first integral? Natural log. Okay, don't forget this is absolute value of x minus 1/10. What would I get for the second one? Natural log of absolute value of x plus 2. The last one, 1/2. There is a 1/2. Be sure that you realize why that's the case. If you are not sure how you get that half for this integral, just do a u substitution by taking u to be 2x minus 1. you'll see that you get half ln of absolute value of 2x minus 1. Everybody's okay with that? Okay, I have accomplished my first goal today, which is go over this entire problem. Our next job will be to basically go over some more examples. And, I only have covered one case where all the factors in the denominator are linear with exponent 1. Now there are other cases when the exponents are not 1. So let's look at a second example. By the way, any questions so far? If you have any questions at all, please let me know. All right, so here's my new example. Let's say now we want to integrate the fraction 4x divided by x cubed minus x squared minus x plus 1. Again, what is the first step? Factor out the denominator. So, okay, well, again, we have to go back to our childhood memory where we were taught how to factor out polynomials, right? If you have taken a college algebra or intermediate algebra, that's where you might have seen this. How do I factor out this? Okay, so what he is suggesting is you want to factor out from the first two terms and you want to factor out the second two terms. From the first two terms, you can factor out x squared and you can get x minus 1. Am I okay with there? And then from the second two factor, I can factor out a negative 1 and write it as x minus 1 as well. Then I can say this is x minus a 1 multiplied with x squared minus 1. Now x squared minus 1 is a quadratic. Is this irreducible or reducible? Reducible, that means I can factor it out. And if I factor out, what do I get? If I factor out x squared minus 1, I get x minus 1, x plus 1. But I can combine x minus 1 with the x minus 1. So x minus 1, we call that a repeated factor. Okay, it is repeated twice. That too means it's the multiplicity of that factor. It's multiplicity, and the meaning of multiplicity that it is repeated twice. Now, so my original fraction then can be written as what? I can write it as x minus a 1 squared times x plus 1. So I accomplished the first step. The second step is what? Write down the partial fraction decomposition. Okay. Remember, in the partial fraction decomposition, each factor in the denominator contributes certain terms, right? Now, what is contributed by x minus 1 squared? Anyone? What is contributed by x minus 1? Okay, very good. Since we don't have too many factors, let's not use subscripts, okay? So, for x minus 1 squared, you're going to have a fraction with denominator with power 1. You're going to have another fraction with denominator x minus 1 squared. If the exponent was 3, then I'm going to have 3 fractions with powers from 1 up to 3. Now, Because these are linear factors, the numerator would be just constants. Yeah. Say it again. No. This is the contribution for x minus 1 squared. Because it's a repeated factor, it contributes 2 terms. Yeah. And the last would be the contribution of x plus 1, which would be c over x plus 1. Everybody gets that. That's really the major first step. I mean, if you get that step, you get 4 out of 10 right away. Okay? All right. Now, what do? We solve for a, b, and c. To find a, b, and c, what do? Was that multiply both sides by the big denominator? Yes.
Can you explain again why it's x minus 1 squared and there's only 2 of them and there's not 3?
You're talking about this?
Yeah, why is it?
So what's the contribution of, remember, if I don't have a 2 here, then the contribution of x minus 1 would be just this. If I have a 2 here, then the contribution of this term will be 2 terms. You will start with exponent 1 all the way up to exponent 2. If I have a 3 here, then you're going to get 3 terms, 1 with each exponent 1, 2, and 3. So you're going to have c over x minus 1 cubed plus d over x plus 1. Everybody is okay with that? Again, I didn't prove to you why that's the case. That's a little bit beyond what we are doing. Okay, but all you need to do is use the fact. All right, now multiply both sides by the denominator. On the left hand side, it's pretty easy. I get 4x. On the right hand side, what do we get? I get a times what? X minus 1, x plus 1, very good. B times x plus 1 and c. Okay. Now let's first solve for b first, okay? If I want to solve for b, what should I plug in? Plug in x to be 1, right? Plug in x to be 1, I get 4 on the left. When I plug in x equals to 1, the a term vanishes, the c term vanishes, and I am left with what? 2b, and that tells me that b is what? b is 2. Now let's plug in negative 1. Plug in x equals to negative 1. If I do that, I get on the left negative 4, right? On the right hand side, when I plug in negative 1, the a term still vanishes, the b term vanishes, and the c term is what? C times what? What's that? 4. It's positive 4, and so I get c to be what? Negative 1. Now how do I get a? How should I get a? Well, now that I know both b and c, right? Now that I know both b and c, I can plug in any number and solve for a, as long as the coefficient of a is not 0. So I need to pick x to be something other than 1 and negative 1. So let's pick 2. So if I plug in x equals to 2, plug in x equals to 2. On the left hand side I get 8, right? On the right hand side, what is the coefficient of a? If I plug in 2 here. So if I plug in 2 right here, I'm going to get 3. Thank you. I'm going to get 3. And if I plug in 2 here, I get b times 2, right? But what is b? b is 2, so I get 4. And when I plug in x to be 2 right here, I get c times a 1, right? But what is c? C is negative 1. So then I get 8 is what? 3x plus a 3. Did I make a mistake? Say it again. Oh yes, thank you. Let me, this number, oops. Give me 1 second, okay, let me erase this. So I'll be getting a 6 here. Go ahead again.
Why does it sit for x?
Right here?
Yeah.
Right here? Oh, if you plug in x to be 2 right here, then you get a times 2 minus 1 times 2 plus 1, which is 3 times 1. So you get 3a. Oh, this is a, yes. Thank you again. Okay, and this will be a. So I get a here. Now this will be a 5, right? And then what do I get? This would be 3 equals to 3a, right? And a is what? 1. So I get a to be 1, c to be negative 1, b to be 2. Everybody is okay with that? Okay, by the way, if you point out any of my mistakes from now on, I'm going to give you 1 point, okay? But make sure you write your name down on a piece of paper and let me know how many mistakes you found, okay? All right. So here's our original fraction, 4x over x cubed minus x squared minus x plus 1, and we wrote it as a divided by x minus 1, so a is 1, and then b is what? B is 2, so this would be 2 over x minus 1 squared, and what was c? Okay, negative 1 over x plus 1. How much time do I have? 1 minute. Okay, let me just point out, at this point if I want to integrate, then I have to integrate this quantity here, right? And what's the integral? It'll be the integral of x minus 1 dx plus 2 times the integral of 1 over x minus 1 squared minus the integral of 1 over x plus 1 dx. What's the first one? The first one would be ln of absolute x minus 1. The second one I'll do later. The third one would be ln of x plus 1 in absolute value plus a c. What's the middle one? The middle one, what do I have to do to find that? I have to do a u substitution because I have 1 over x minus 1 squared. So if I take x minus 1 to be u, I am going to get 1 over u squared, which will be u to the negative 2. And the antiderivative of that is what? Negative 2 plus 1 divided by negative 2 plus 1. So it's e to the negative 1 over negative. So it's negative 1 over u, which is negative 1 over x minus 1. Again, I did that without showing you the work, but I think you could do it on your own. Use a U substitution to figure out what is that integral, okay? So this is it for this example. We still have to do a few more examples from this section. Once again, the exam is next week on Friday. This week on Friday, you're going to have a quiz though, and the quiz will be on 7.3. Remember I gave you a handout on 7.3? That's what will be on the quiz. Yeah.
We have a track meet Tuesday, Thursday night, so we won't be doing that.
Monday?
The Monday following?
Yeah. Just take it on Monday, unless you want to take it tomorrow.
Okay. We're talking about next week.
Next week,
Oh, next week on Friday, the exam.
the exam.
You might want to take the exam. Yeah, take it following Monday or Thursday before that, because we will be done with the syllabus for the exam this Friday.
Okay.
So you have a choice to take it early or later.
Okay.